Hi everybody, welcome back. Let's continue where we left off last time. Are you looking forward to graphing those 4 limaçons? Guess what? The only trig values we'll need are these. Really? Yep. You know these very well, right? Okay. Here's limaçon number 1. To draw limaçons, all we have to do is plug in a few standard theta values. When theta is 0, cosine 0 is 1. We get r is 3 minus 1, r is 2. There's that point. When theta is pi over 2, cosine pi over 2 is 0, r is 3. There's that point. Keep going. When theta gets to pi, cosine pi is negative 1. R is 3 minus a negative 1, we get 4. And there's that point. When theta is 3 pi over 2, cosine of that is 0. R is 3. There's that point. There it is, the convex limaçon. Of course, if we want a more accurate graph, we will have to plug in a lot more points. But by observing where the tangent lines are vertical or horizontal in some of the cases, or how they slant, will be enough to make our graphs look correct. Okay, limaçon number 2. Let's plug in points. When theta is 0, sine 0 is 0, r is negative 1. So where's that point? There it is, because we have to jump to the opposite side. When theta is pi over 2, sine pi over 2 is 1, r is 0. We get the pole. When sine is pi, sine pi is 0, r is negative 1. So jump to the other side, and there's that point. When theta is 3 pi over 2, that's the y-axis pointing down, we get r is negative 1 minus 1, that's a negative 2. Jump to the other side, and we get that point. And here's the cardioid. The point at the pole is a cusp, C-U-S-P. The tangent line is vertical in this case. The tangent line on the top point is horizontal, and notice how it slants on the 2 sides. Here's example 3. We already know this represents a dimpled limaçon, so let's plug in the points and see what happens. When theta is 0, r is 3 plus 0, we got 3. There's that point. When theta is pi over 2, we got 3 plus 2, that's 5. There's that point. When theta is pi, sine pi is 0, r is 3. There it is. And when theta is 3 pi over 2, sine of that's negative 1, we get 3 minus 2, that's 1. And there's that point. That's where the dimple is. And here's the dimpled limaçon. Notice in this case, at the dimple, there's a horizontal tangent line. On the top, there's a horizontal tangent line, and the 2 sides are slanted. Okay, last one. Let's not worry about the inner loop. Do the same thing, plug in theta values. When theta is 0, cosine 0 is 1, r is 2 plus 3, we get 5. There's that point. When theta is pi over 2, cosine of that is 0, r is 2. There's that point. When theta is pi, cosine pi is negative 1. R is 2 minus 3. We get negative 1. Look what happens. We get the point over there. That's going to be the end of the inner loop. When theta is 3 pi over 2, cosine of that is 0, r is 2. There it is. Can we prove that this graph really goes through the origin? Sure. Just set r equals 0. We find that cosine theta is negative 2 over 3. If we draw that angle, we'll have the tangent lines to the curve at the pole. But for our purposes, this is good enough. Notice for this limaçon where the vertical tangents are. At the pole, there are slanted tangent lines, and also along the y-axis, those are slanted. Was that easy? I hope you have fun drawing a few more. Bye.